And the next, I'll share you the recording of this after the session. Okay, and then ನೋಡ್ಕೊಂಡು ಬರ್ಕೊಳ್ಳಿ ಬೇಕಾದ್ರೆ. The next thing, cause for the refraction. You can see the cause for the refraction here. Light travels with different speeds in a different medium. That itself is a cause. Light bend ಆಗುತ್ತೆ because it travels in different velocities. Examples for refraction. Objects underwater appear to be raised when viewed from the surface. And second one, twinkling of stars. And the meaning of lateral shift. It is the perpendicular distance between the incident ray extended and emergent ray. This is the incident ray and here is the emergent ray. The perpendicular distance between them is called lateral shift. So next is normal shift. It is the apparent shift in the position of the object placed in the one medium and viewed along the normal from the another medium. So this is the apparent shift meaning. Zero object in other, so it will be appear to be.
Sir, voice break ಆಗ್ತಾ ಇದೆ.
Wait a minute.
ಮಾಡಿದ್ರೆ ಕೇಳಿಸ್ತಾ ಇಲ್ಲ ಒಬ್ರಿಗೆ.
Yes, sir.
Yeah, now is it clear? You are ಕೇಳಿಸ್ತಾ ಇದೆಯಾ?
Yes, sir.
Yes, sir.
Is it clear now?
Yeah, sir.
Okay. So understood the meaning of normal shift? Nodi, the object is actually placed at the
Sir, previous slide explain ಮಾಡಿ.
previous slide. Cause for refraction. Light travels with different speeds in different medium. ಹಾಗಾಗಿ light bend ಆಗುತ್ತೆ. Okay, lateral shift ಅಂದ್ರೆ, so when you take the parallel sided glass slab, this is actually incident ray path and this is the emergent ray path. So ಈ ಎರಡರ ನಡುವೆ ಇರುವಂತ perpendicular distance ಇದನ್ನ ನಾವು ಏನಂತ ಹೇಳ್ತೀವಿ, lateral shift ಅಂತ ಕರಿತೀವಿ. Okay, perpendicular distance between the incident ray extended and the emergent ray. And this is the next one, normal shift. It is the apparent shift in the position of the object placed in one medium when viewed along the normal from the another medium. So here is the object, but it appears to be shifted somewhere here near to the surface. So a shift from the object to image, that is called normal shift. Real depth, it is the distance between the object and the refracting surface. So the surface is the actual object will the distance. Apparent depth from the surface to image, that distance is called apparent depth. Okay. Comment in the chat box, whatever the doubts you have. Yes. Next, moving to the definition of refractive index. So refractive index, the symbol is here. Okay, so actually the meaning is velocity of light velocity of light in first medium to the velocity of light in second medium. Velocity of light in first medium to velocity of light in second medium. The ratio of velocities ನಾವು refractive index ಅಂತ ಕರೀಬಹುದು. Okay. Or we can also use the depth concept. Refractive index of a material can be known from real depth divided by the apparent depth concept. Apparent depth ಹೀಗೂ ಕೂಡ ಹೇಳ್ಬೋದು. Okay. So this is the refractive index meaning. So we can also call it as a relative refractive index ಅಂತ ಕೂಡ ಹೇಳ್ತೀವಿ. Absolute refractive index ಅಂತ ಇನ್ನೊಂದು. Absolute refractive index. The meaning of this is the first medium must be a vacuum. Okay. Velocity of light in vacuum. ಮೊದಲನೇ medium vacuum ಆಗಿರಲೇಬೇಕು. And the second medium may be any other. Velocity of light in denser medium. So this ratio is called absolute refractive index. Please copy this. I'll show you once again all the slides at the end. ಇವಾಗ ಮಾಡ್ತಾ ಇರೋದನ್ನ ನೀಟಾಗಿ ಅರ್ಥ ಮಾಡ್ಕೊಂತ ಹೋಗಿ. Refractive index. Refractive index ಅಂದ್ರೆ ಏನು? Ratio of two velocities in two different mediums. ಇದನ್ನ ನಾವು real depth by apparent depth ಅಂತಾನು ಡಿಫೈನ್ ಮಾಡ್ತೀವಿ. Absolute refractive index means the first medium must be vacuum. After that, we have a very important question, that is state the laws of refraction. Okay. ಅಥವಾ ಇದನ್ನು ಸ್ನೆಲ್ಸ್ ಲಾ ಅಂತಾನು ಕೇಳಬಹುದು. First law, laws of refraction. The incident ray. So refraction diagram ನೋಡಿದಿರಿ ಆಗಲೇ. So ಅದರಲ್ಲಿ incident ray, the refracted ray, and the normal draw. And the normal draw to the refracting surface. Refracting surface all lie in the same plane. Same plane and meet at same point. Okay. So this is the refraction surface, refracting surface. This is the normal draw, and here is the incident ray, and here is the refracted. So incident ray, refracted ray, normal drawn to the refracting surface, all are lying on the same plane. ಇದು ಮೊದಲನೇ. First law. Next, second law. So here is the angle of incidence. Here is the angle of refraction. Right? So second law we can write like this. N is equal to sin I divided by sin R. It means the ratio of sine of the angle of incidence to the sine of the angle of refraction. Sine of the angle of refraction is equal to a constant. Okay, that constant is called refractive index. Now these are the two laws of refraction. Very important 2-mark question. Davia has a question. Absolute refractive index, second medium be a rarer also. Actually, vacuum is a rarer medium. That is the least rarer. Whatever the medium comes than the vacuum, even if you consider air also, that will be considered as a denser than compared to the vacuum. Right? So it cannot be a rarer than a vacuum. Vacuum is only the rarer medium, right? Understood, Davia? Yes. Okay. Going to the next. Limitation of Snell's law. Limitation of Snell's law. So what is the limitation? It is not applicable for a normal incidence because through the normal, if light enters, it never suffers the deviation, right? So it is not applicable for normal incidence. Hope you all understood. Yeah, I'm also writing. I can't give extra writing time. Please keep writing how I'm writing now. So total internal reflection, the next concept, very important. So we also call it as a TIR in short form. Total internal reflection. So what is the meaning of this? So I'll take then refracting medium. So here it will be the denser medium. Okay. In the denser medium, here I'll place the light source. This is the light source. Okay. When the light travels along the normal, it never suffers any deviation, right? It goes straight. This is along the normal. But if it enters obliquely, okay, when it enters obliquely, it goes away the normal, like this. Angle of incidence is the angle of refraction. But if still the angle of incidence increases, at particular angle of incidence, the light grazing over the surface. Okay. I'll show you here some different color. This is the light grazing. Light is grazing over the surface. This is the angle of refraction, 90 degrees. So this particular angle we call as a critical angle. So 1-mark question you get, what is a critical angle? It is the angle of incidence in a denser medium. Okay. At which the angle of refraction is 90 degree, or for which the refracted ray grazing over the surface. Understood? And still, if any light rays goes above the critical angle, greater than a critical angle, if it is incident, it falls back internally into the same medium. Okay, this is the total internal reflection. So what is the condition for this? The angle of incidence must be greater than critical angle. Okay, so the critical angle is lesser than the angle of incidence. The TIR is observed. Completed? Please comment. Is it understood, students? Total internal reflection. Okay, okay. Now I'll write the necessary condition for total internal reflection. So first we study what is critical angle, the definition. Critical angle is the angle of incidence angle of incidence in the denser medium for which the angle of refraction is 90 degree. Angle of refraction is 90 degree. Okay. Next, conditions for total internal reflection. Union conditions ಇರಬೇಕು. Okay, ಮೊದಲನೇ condition ಏನು? Light must travel from denser to rarer. That is the first condition, right? Light must travel from denser to rarer medium. Okay. And the second condition is angle of incidence. Angle of incidence in denser medium must be greater than the critical angle. These are the two conditions for total internal reflection. Okay. Next, what will be the relationship between critical angle and refractive index? Very, very important. Okay. Relation between critical angle and refractive index. Because denser medium, I can take either the glass or water, whatever it is, right? So critical angle ಮತ್ತು refractive index vary ಆಗುತ್ತೆ ಅನ್ನೋದಕ್ಕೆ ಇದೊಂದು formula. Sin C is equal to, okay, we can write here refractive index of rarer medium divided by refractive index of denser medium. ಇದನ್ನು ನಾವು n2 by n1 ಅಂತ ಬರೀಬಹುದು. In case rarer medium, if we select it as a air ಅಥವಾ vacuum ಅಂತ ತಗೊಂಡ್ರೆ, so that will become 1, right? So for air or vacuum, we consider n2 as a 1. Therefore, sin C is equal to, we can write it as a 1 by air. Our critical angle is inversely proportional to the refractive index. Greater the refractive index of the material, least is the critical angle. Next is applications. Applications of total internal reflection. The total internal reflection concept use ಆಗುತ್ತೆ. ಮೊದಲನೇದಾಗಿ used in total reflecting prisms. Total reflecting prisms. Okay, ಈ ಪ್ರಿಸಮ್ಗಳನ್ನ ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ ಅಂದ್ರೆ ಬೈನಾಕ್ಯುಲರ್ಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. Binoculars and they used in periscopes. ಅಲ್ಲೆಲ್ಲ ಈ ಟೋಟಲ್ ರಿಫ್ಲೆಕ್ಟಿಂಗ್ ಪ್ರಿಸಮ್ಸ್ ಅನ್ನ ಯೂಸ್ ಮಾಡ್ತಾರೆ. ಎರಡನೇದಾಗಿ used in optical fibers. Optical fibers ಅನ್ನು ಯೂಸ್ ಮಾಡ್ತಾರೆ. Very important. Okay. So optical fiber ಅಂದ್ರೆ ಏನು ಅಂದ್ರೆ, it is a device worked based on the principle of total internal reflection. It is used to transmit the light in a desired path. Okay, can write that it works on TIR. It is used to transmit. Used to transmit the light in desired path. Okay, light signals ಅನ್ನ ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ಕರೆಂಟ್ ಗಿಂತಲೂ ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ಕಳಿಸಬಹುದು ಈ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್ ಮುಖಾಂತರ. ಓಕೆ, ಸೊ ಈ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್ ಗಳು ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಆಗುತ್ತೆ? ಸೊ ಯೂಸಸ್ ಆಫ್ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್ ಕೇಳ್ತಾರೆ. Uses of optical fibers. ಮೊದಲನೇದಾಗಿ used in telecommunications. Second one, used in table decorative lamps. Table decorative lamps. And used in endoscopy. Okay, to treat the ulcers or whatever it is, intestinal parts. Okay, laparoscopies, ಇವೆಲ್ಲ ಟೆಕ್ನಿಕ್ಸ್. ಸ್ಟಮಕ್ ಒಳಗಡೆ ಏನಿರುತ್ತೆ ಕಾಯಿಲೆಗಳು ಅಥವಾ ಬ್ಲೀಡಿಂಗ್ ಆಗ್ತಿದೆಯಾ, ಎನಿಥಿಂಗ್. ಓಕೆ, ಸೊ ಈ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್ ವಿಲ್ ಬಿ put through the throat. Okay, so it will act like a camera. So they will watch through the optical fiber. This technique is called endoscopy. These are uses of optical fibers. High total internal reflections are now reliance of diameter. Allu kuda nodabodu. Okay, total internal applications of TIR ಇದರಲ್ಲಿ ಮೊದಲನೇದು total reflecting prism. ಎರಡನೇದಾಗಿ ಆಪ್ಟಿಕಲ್ ಫೈಬರ್ಸ್ ಅಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾ ಇದ್ದೀವಿ TIR. ಅದೇ ರೀತಿ ಥರ್ಡ್ ಒನ್ used in reliance of diamond. lens of diamond. So diamond yaak shining ಆಗುತ್ತೆ ಅಂದ್ರೆ that is due to total internal reflection because it is having many edges. ಪ್ರತಿಯೊಂದು edge ಅಲ್ಲೂ ಕೂಡ light ಒಂದ್ಸರಿ ಎಂಟರ್ ಆದ್ಮೇಲೆ ಏನಾಗುತ್ತೆ it's keep reflecting from each surfaces. Hence it appears to glow. So this is what we call brilliance. Yeah. Okay, I'll show from the beginning once again. ಮತ್ತೊಂದ್ಸರಿ ಹೇಳ್ಬಿಡ್ತೀನಿ ನೋಡಿ. I'll come from beginning. Ray optics. Ray optics means it is a branch of physics which deals about the study of light. Okay, ಇದನ್ನು geometrical optics ಅಂತಾನೂ ಕೂಡ ಕರೀತೀವಿ. ಇದರಲ್ಲಿ ಮೊದಲನೇದಾಗಿ refraction, so bending of a light when it travels from one medium to another medium. So what is the main reason? Because light travels from different speed in different medium. ಗಾಳಿನಲ್ಲಿ ಒಂದು ಸ್ಪೀಡ್ ಇದ್ರೆ ನೀರಿನಲ್ಲಿ ಒಂದು ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಟ್ರಾವೆಲ್ ಆಗುತ್ತೆ. ಹಾಗಾಗಿ ಏನಾಗುತ್ತೆ ಲೈಟ್ when it enters from air to water it bends, water to glass it bends because optical density is different for a different mediums. Examples to that. Any two examples you can give for the refraction? Any object kept under the water, it appeared to be raised, alva? Adu kuda refraction example. Next, twinkling of a star, refraction example. Next, lateral shift. See, this is the incident ray and this is the emergent ray at the end. This is actually the incident path. ಇವೆರಡು ನಡುವೆ ಇರುವಂತ perpendicular distance ಅನ್ನ lateral shift ಅಂತ ಕರೀತೀವಿ. Normal shift. It is apparent shift in the position of the object placed in one medium when viewed from the normal in another medium. The meaning of real depth and apparent depth. Then the meaning of refractive index. It is just a ratio of velocities or speeds of light in two different mediums. V1 by V2. Or in terms of depth, real depth by apparent depth. Next, absolute refractive index. Here we take the first medium as a vacuum. So vacuum is the rarer, very rarer medium. ಅದಕ್ಕೂ ತುಂಬಾ rarer ಇನ್ಯಾವುದು ಇರೋದಕ್ಕೆ ಚಾನ್ಸ್ ಇಲ್ಲ. ಹಾಗಾಗಿ the next medium will be denser. Even if you consider air also, that will be the denser with respect to vacuum. Next, state the laws of refraction. Two laws of refraction. Incident ray, refracted and normal, all lie on the same plane and meet at the same point. Second law, ratio of sine of the angle of incidence to the sine of angle of refraction is equal to a constant. That constant we can take it as a refractive index of the medium. Limitation, it is not applicable for normal incidence. Next concept, total internal reflection. Here you can see light must travel from denser to rarer medium. Light source denser ಇರಬೇಕು. Okay, and at particular angle of refraction becomes 90 degree and refracted ray grazing over the surface ಮೇಲೆ ಹೋಗುತ್ತೆ ಆ ಲೈಟ್. ಇಲ್ಲಿ ರೆಡ್ ಮಾರ್ಕ್ ಅಲ್ಲಿ ಬರೆದಿದೆ. ಸೊ ಈ ಒಂದು ಆಂಗಲ್ ಆಫ್ ಇನ್ಸಿಡೆನ್ಸ್ ಅನ್ನು ಕ್ರಿಟಿಕಲ್ ಆಂಗಲ್ ಅಂತ ಕರೀತೀವಿ. Okay, and any angle of incidence greater than critical angle, then the reflected light will falls back into the same medium. This is called total internal reflection. Okay, so the condition for TIR is this: light must travel from denser to rarer, angle of incidence must be greater than critical angle, and relationship between the critical angle and refractive index. Sin C is equal to refractive index of rarer medium by refractive index of denser. So N2 by N1. If you select the rarer medium as a air or vacuum, then sin C becomes 1 by N. Next is applications of TIR. ಎಲ್ಲೆಲ್ಲಿ ಯೂಸ್ ಮಾಡಬಹುದು ಅಂತ. ಮೊದಲನೇದಾಗಿ total reflecting prisms ಗಳಲ್ಲಿ ಯೂಸ್ ಮಾಡ್ತಾರೆ. And these prisms are used in binoculars and periscopes. And next we use in optical fibers. Okay, so these are the light pipe ಅಂತ ಕೂಡ ಕರಿತೀವಿ. ಸೊ ಇಲ್ಲಿ ಹೋಗುವಂತ ಸಿಗ್ನಲ್ಗಳು ಲೈಟ್ ಸ್ಪೀಡ್ ಅಲ್ಲಿ ಹೋಗುತ್ತೆ. ದಟ್ ಈಸ್ ಫಾಸ್ಟರ್ ದ್ಯಾನ್ ಅ ಕರೆಂಟ್. ನಾವು ಕರೆಂಟ್ ಅನ್ನ ವೈರ್ ನಲ್ಲಿ ಕಳಿಸ್ತೀವಲ್ಲ ಅದಕ್ಕಿಂತಲೂ ತುಂಬಾ ಫಾಸ್ಟ್ ಆಗಿ ಹೋಗುತ್ತೆ. ಸೊ what we are receiving nowadays, the internets and all, that is the optical signals. Through the optical fibers we are getting the signals. Okay, it works on the total internal reflection principle and use it to transmit the light in desired path. ನಮಗೆ ಬೇಕಾದ ಕಡೆ ಲೈಟ್ ಅನ್ನ ಕಳಿಸಬಹುದು. ನೋಡಿ, ಲೈಟ್ ಅನ್ನ ಬೆಂಡ್ ಮಾಡೋದಕ್ಕಾಗಲ್ಲ ಅಂತ ಗೊತ್ತು ನಮ್ಗೆ, ಬಟ್ ಇದ್ರ ಒಳಗಡೆ ಫೈಬರ್ ನ ನೀವು ಹೇಗೆ ಬೆಂಡ್ ಮಾಡ್ತೀರೋ ಲೈಟ್ ಹಾಗೆ ಬೆಂಡ್ ಆಗ್ತಾ ಹೋಗುತ್ತೆ. ಯೂಸಸ್ ಟೆಲಿಕಮ್ಯುನಿಕೇಶನ್, ಟೇಬಲ್ ಡೆಕೋರೇಟಿವ್ ಲ್ಯಾಂಪ್ಸ್ ಗಳಲ್ಲಿ, ಮತ್ತೆ ಎಂಡೋಸ್ಕೋಪಿ ಟೆಕ್ನಿಕಲ್ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಓಕೆ, ಮತ್ತೆ ಆಡಿಯೋ ವಿಡಿಯೋ ಸಿಗ್ನಲ್ಸ್ ಗಳು ಕಳಿಸೋದಕ್ಕೂ ಕೂಡ ಯೂಸ್ ಮಾಡ್ತೀವಿ. ಅಂಡ್ ಬ್ರಿಲಿಯನ್ಸ್ ಆಫ್ ಡೈಮಂಡ್, ಡೈಮಂಡ್ ಯಾಕೆ ಗ್ಲೋ ಆಗುತ್ತೆ ಅಂದ್ರೆ ದಟ್ ಈಸ್ ಆಲ್ಸೋ ಡ್ಯೂ ಟು ಟೋಟಲ್ ಇಂಟರ್ನಲ್ ರಿಫ್ಲೆಕ್ಷನ್ ಫ್ರಮ್ ಮೆನಿ ಎಡ್ಜಸ್. Yeah, anybody having any doubts?